first come across it in third year, it just often doesn't make any sense. So I'm hoping that now your brains are more mature and you'll find it easier to do. But the key thing I have found in all my years of teaching is to have a structure to how you approach a question makes all the difference in the world. And part of that structure is drawing a diagram and labeling the diagram correctly, and that should help you to find it easier to do trig. So trigonometric ratios is what we're looking at here. Basically, trigonometric ratios is the words that they give to sine, cosine, and tangent. Okay. Could you just check that your mic is muted if it's not already? Okay. So sine, cosine, and tangent. Now we often call those sine, cos, and tan. Sin, cos. So we call that sin, cos, and tan. So the cosine is pronounced as if it's a Z for cos and tan. And we use these particular trigonometric ratios only in right angle triangles or in rats. We can only use them in right angle triangles. You can't use these particular ratios in triangles where there's not a right angle. Now, before we start, you may remember back to your junior cert, or even you might have done some in TY, and you had this thing called SOH CAH TOA. SOH CAH TOA, okay? Now, in my class, when I teach this, I use the one that my maths teacher taught me many years ago, which is which is silly old Harry. Silly old Harry. And then for cosine, it's caught a herring, so adjacent over hypotenuse, A over H for cosine. And I'll explain these words now in a minute. So caught a herring, which, as you know, a herring is a type of fish. And tangent or tan is trawling. Oh, I wrote trawling. I should have written. Sorry, I am having a bad day. Opposite, trawling off America. Tan is opposite over adjacent. Trawling off America. So I don't mind whether you remember SOH CAH TOA or just remember the ratios, or silly old Harry caught a herring trawling off America, or some other way of doing it. But anyway, what do all these opposite and hypotenuse and adjacents mean? Well, hopefully you remember, and I'll go through it now in case you don't. If you have a right angle triangle, so what I'm going to do is I'm going to draw, that's not great, a heap of right angle triangles here, and we'll look at them, each of them in turn, and hopefully the more we look at, the easier it'll be to see what's happening. As you can see, my art continues to astound everybody. I used to think I was quite good at art when I was small, but anyway, we won't get into that now. Okay, so there's a variety of right angle triangles. Remember, this thing here means it's a right angle triangle. Okay, so because that's a right angle, we know immediately straight away that the side opposite the right angle is the hypotenuse. So let's fill that in. Now, hypotenuse, we're going to use H for hypotenuse. So let's just write that down here. H is equal to hypotenuse, which is the side opposite the 90-degree angle. Okay, so that's our hypotenuse. There's our hypotenuse in that triangle. There's our hypotenuse. There's our hypotenuse directly opposite, and our hypotenuse is here. And remember, we said earlier today that the hypotenuse is always the longest side. So that's our hypotenuse. That's fair enough. No matter what else happens, our hypotenuse is opposite the right angle. Now, for us to be able to put in our opposites and our adjacents, which we're going to need for these, and we'll talk more about what these are tomorrow, in order to be able to label something an opposite or an adjacent, I need to decide which angle I'm talking about. So I'm just going to put in some angles here. I'm going to call this angle B. I'm going to call this angle B. I'm going to call this angle B, this angle B, and this angle B. Okay, so those, in each case, that's the angle that I'm referring to. And the labeling of the triangle does depend which angle in the triangle you're using. So in this triangle, the labeling for this triangle is all based on this angle B being the angle we're talking about, because our trigonometric ratios of sine, cos and tan all refer to a particular angle in a triangle. So in this case, let's call it B. So sine B, cosine B, and the tangent of B. So sine B, cos B, or tan B, okay, they are going to be the angles we're referring to. Now, what does that mean? That means if I have this triangle here, this is my hypotenuse, I've got two other sides to fill on this. One of them is the opposite and one of them is the adjacent. That means one of them is the side that is opposite side B. We call that O for opposite. And one of them is the side that is adjacent to or next to. That's what adjacent means. Next to angle B. So the side that's opposite across the triangle from angle B is called the opposite. The side that's next to angle B is called the adjacent. Okay, here the side opposite angle B is the opposite. The side that's next to or adjacent to angle B is the adjacent. The side opposite angle B is the opposite. The side next to angle B is the adjacent. Okay, the side opposite angle B is the opposite. The side next to angle B is the adjacent. And the side opposite angle B is the opposite. The side next to angle B is the adjacent. Okay, so as you can see here, it depended which angle we talked about, which side was the opposite and which side was the adjacent. The hypotenuse was always in the same place, but the adjacent and the opposite depend on which angle we've chosen. Okay, let's take an example here. Say we have this triangle which keeps popping up again and again. I don't know whether you've noticed it. We have a triangle that pops up again and again, which is a classic triangle called a 3, 4, 5 triangle. 3 squared is 9, 4 squared is 16. Add them together, we get 25. 3, 4, 5. Okay, that's a right angle triangle. If I was to find out if I was to find out what the sine, the cos and the tans were in relation to this, then this is how I would do it. Okay, so let's call this angle B and let's label our triangle. So as we said before, we always do the hypotenuse first because it's always opposite the right angle. So that's my hypotenuse, or H. The opposite is going to be the side that's across the triangle directly opposite the angle. So this is the opposite. The adjacent is going to be the side that's adjacent to or next to my angle. So that's 3, which is the adjacent. Now, what does that mean? That means that my angle B in this triangle, the sine of angle B was what? It was opposite over hypotenuse. Silly old Harry, or SOH CAH TOA. Let's write SOH CAH TOA here. SOH CAH TOA. Okay. The sine of B is opposite over hypotenuse, which equals, opposite is 4 over hypotenuse, which is 5, which is 4 over 5. Sine B is 4 out of 5. Now, if you can't remember what to do next with that, don't worry, we're going to talk about it in a moment, but hopefully you'll remember that we then go on and use that. Cos B is CAH, C-A-H, cos is adjacent over hypotenuse, and in this case it's 3, which is the adjacent over the hypotenuse, which is 5, and tan B is opposite over adjacent, O over A, which is 4 over 3. So hopefully you can see where those ratios came from. Remember, we labeled our triangle, we put the hypotenuse opposite the right angle. We said this was the angle B we were talking about. The opposite in that triangle then is the side that's opposite angle B, so it's over here. The other side, the one that's next to angle B or adjacent to angle B, is the adjacent. And then we said sine was opposite over hypotenuse, 4 over 5, 4 over 5. Cos B was adjacent over hypotenuse, which is 3 over 5. And tan B was opposite over adjacent, which is 4 over 3. Now, what do we do in that case? Well, any one of these ratios, sine, cos, or tan, will help us to solve and find out. Say we were being asked to find the size of the angle B. Okay, find the size of the angle B. Any of these will allow us to find the size of the angle. Okay, and I'm just finishing it off here. The main part is how to label the triangle and writing out sine, cos, and tan. We're going to talk lots of times about how do we find the angle or find the side, but just for now, to finish it off, what would we do? Sine B is 4 over 5. There's an angle that when I put it into my calculator and I put in sine and I put in the angle and I press equals, I'm going to get 4/5. But if I already know the sine and I don't know the angle, I have to go the other way, and going the other way in maths has often got a -1 after it. So if I'm trying to find the angle from the sine, then I do sine, I'm working backwards, sine inverse 4 over 5. So if you have your calculator, you could try that. Sine inverse 4 over 5. So I do shift sine, and then I put in my fraction 4 over 5 equals. And it tells me that it's 53.13 degrees. Now I'm just going to get you, if you didn't get that answer, just double check, because up on the top there, at the very top of your screen, you should see, there should be a little D, which means degrees. If you got a different answer, it could be that you have a little or a little G up there. And the way you change that is that you do mode. No, you don't do mode. Let's try again. You do shift mode, and then you make sure you do 3 for degrees, and that'll make sure degrees is there. Okay, so you do shift mode, so in other words setup, and make sure you press 3 for degrees. So I've got that the sine, the angle that has a sine of 53.13 degrees is, the angle that has a sine of 4/5 is the angle 53.13 degrees. I could use any of these ratios and I would always get 53.13. Let's just check and see. Cosine inverse 3/5. If I do that on my calculator, so shift cos 3 over 5 equals 53 degrees, 53.13 degrees. And if I try the tan, shift tan 4 over 3 is 53.13 degrees. .13 degrees. Now, I'm not going to go into why these work or how they came up with them in the first place, but what this is all based on is the idea that any angle of 53.13 degrees, if you draw a triangle with that as one of the angles, then the sides will always give you a ratio that is in the same ratio as 4:5 or 3:5 or 4:3. But that might not help you, so we won't dwell on that. Okay, so what did we say at the start? We said that these were ratios for right angle triangles. We said the important thing was to know how to label your triangle, and I always strongly recommend that you label the triangle and draw a sketch if there isn't one for you. You need to be able to label the hypotenuse, the opposite, and the adjacent. Once you've labeled the triangle, then you can, if you know the sides of the triangle, you can work out the angle by using sine, cos, or tan. For now, we haven't done that, but we might do one more example now before we go, and you can try it out and see. The main thing is sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, let's just take one more triangle here. If you want to draw a sketch of a triangle, we'll use one of the other classic triangles, which is 5, 12, and 13. Okay, any triangle with sides 5, 12, and 13 will be a right angle triangle. And let's use this angle up here and call it B. So if you could draw that sketch into your copybook, a rough sketch of a right angle triangle, and call one of the angles B. If you want to do the exact same triangle as mine there, you'll be able to compare it more easily, but it'll work anyway. As long as B is the angle opposite the smallest side, the side 5, okay? Otherwise you're going to get different answers to me. So label your triangle, write in your hypotenuse, your adjacent, and your opposite. And just use O, A, and H is fine. Okay, so hopefully you've labeled it and you've got the same answers as me if you've chosen the same angle. So now sine B, SOH CAH TOA. So can you write down the ratios for sine B, cos B, and tan B? So hopefully what you've got is you've found out that sine B is 5 over 13, that cos B is 12 over 13, and that tan B is 5 over 12. Now, the last thing we're going to do is, let's say that instead of this being the angle, we actually decided to do this angle. We called it X or Y or C or something. And we did the other angle in the triangle. What you'll notice is that our labeling changes. So here this stays the hypotenuse because it's the side opposite the right angle. So it's always the hypotenuse. But if you notice, the side that's opposite our angle is now this angle, this side here, the side that's 12. And the side that's adjacent to our angle is actually this side, 5. So when we come to write down the sine, the cos, and the tan of this angle, the other angle in the triangle, what we get is that the sine of the angle is the opposite, which is 12, over the hypotenuse, which is 13. The cos of the angle is the adjacent over the hypotenuse, which is 5 over 13. And the tan of the angle is the opposite over the adjacent, which is 12 over 5. So it's very, very important that you're doing the correct angle, the appropriate angle in the triangle that you draw.